So good morning, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hampeyo Kliman. So of course today we shall be doing quite a lot of questions, your physics 2024 test 1, and I'm going to show you just how to solve all the concepts about this particular topic. And friends, I would also want to invite you for this Breaktober night 2025, which is going to be held on the 23rd of October this same month, which is going to start at exactly at around 18 hours to 05 hours. So it's going to be an overnight, and it's going to take place from the President Stadium mine area near Comet Grounds. So of course, to those of you that are familiar with our ministry, Upper Room Prayer Power Embassy with Apostle Alex Bisi Mutale, you know that there is already a bus pickup for all for the students at Mulungushi University that would want to come for the overnight. Ensure that you get in touch with me, or you call the numbers on the screen, but it is important that you get in touch with me. Okay, so of course this is I think you've seen many posters in town about this particular night. Don't you miss this night. It's going to be amazing. The presence of God is going to be there. It's going to help you. It's going to change your life. Your relationship with God is going to be solid. Your academics. This is a man that has been there for me. He's been a good father to me, and a mentor, a coach, and I love him so much. So make sure that you attend this night, of course. That is the mentor with Apostle Alex B. Semutal at Upper Room Proper Embassy. This is our night, the Breaktober night, which is, of course, occurring on the 23rd of October, 18 hours to 05 hours sharp. Okay, so don't you miss this particular night. Get in touch. I'm going to put a number on the screen. The number that you're going to call me on is going to be so this is going to be my WhatsApp number. It's going to be a plus 260 66 40 46. So that's the number you're going to inbox me on WhatsApp, and of course we shall be able to link up. We start our calculations. It's going to be an amazing physics tutorial. I'm going to show you the easiest ways to go about these particular concepts. We start. We have the first question is saying, what is an approximate value for the speed of sound in air? The approximate value for the speed of sound in air. So for the first one, I'm sure it's very easy. You already know that the approximate value for the speed of sound in air, it's about 331 meters per second, but because there is a 300 flat, we can get it. So of course our answer is going to be B, which is simply giving us a 300 meters per second. We go to the second question. Is saying a projectile is fired in such a way that its horizontal range, okay, is equal to 3 times its maximum height. What is the angle of projection? So for this question, they have told us that this projectile motion, with this projectile, when it was fired, its horizontal range, the horizontal range was equivalent to 3 times the height. Okay, 3 times the height. But we know that the range, okay, the range can also be written, the range can be found using this particular formula. Okay, there is a range in the for a projectile which is making a trajectory in the x, and then there's a range for a projectile which is making a trajectory in the air but considered in the x. So for such a one, you need to understand that the range is going to be calculated using the velocity y to the power 2, then sine 2 theta over g. Okay, then of course you know that under projectile motion, the height Okay, the height is calculated using the formula v y to the power 2 over 2g. But we know that v2y is just the same as v sine theta. So while there is this guy, I can replace with that. Okay, I can replace with that. So when I do my replacement, I'm going to have height is going to equal to v power 2. Okay, v power 2. Sorry, there's supposed to be a power 2 here because this v is having a power 2. So v power 2 sine theta over, this is going to be 2, the gravity, like that. Okay. So now we have both the range and the height. What then do we do? We can get our equation here. So we are going to say our v y power 2 sine 2 theta over the acceleration due to gravity is going to equal to 3 open bracket. Then what there is height, I can replace this particular expression. So it's going to be v power 2 sine theta over 2. Okay, upon reaching here, we can cancel what is similar. So of course we know before we even cancel, this can also be written as vy power 2 sine 2 theta over g is going to be written as 3 over 2. Then this is going to be v to the power 2, then sine theta, like that. So of course we can cancel out what is present on both sides, which is similar. Okay, this is also a y. We know that. Okay, so we know that there's a velocity here, there's also a velocity there. Okay, in the y, there's a velocity there, there's a velocity there, they can cancel. What else is able to cancel on the other end? Okay, what else is able to cancel on the other end? So I forgot to put a 2g here. So of course we have a g here. Okay, we have a g, gravitational shoot force here. So our g there can cancel. What else is able to cancel on the other end? Even this g is able to cancel. So when we cancel those guys, we are going to have something like sine 2 theta is going to equal to 3 over 2. And then we're going to have a sine theta here. Okay, a sine theta. Okay. Sorry, I moved the 2 outside, so it's not supposed to be here. I'm going to have a sine theta here. Okay. So now after having a sine theta here, what are we going to do? We want to find an angle of projection. Okay, we want to find an angle of projection. But when you look at this guy in mathematics, if you did trigonometry, then you already know that we can use the double angle identity, because we know that in mathematics, sine 2 theta is the same as 2, then you just repeat that guy there and its opposite. That's just one and the same. So I can put my 2 sine theta, then cosine theta here, then this is going to be 3 over 2, then sine theta, like that. Then this is just the same as okay, sorry. So this is supposed to be, the h is supposed to be height is equal to, remember I said height was equal to v to the power 2 over 2g, meaning if you replace where there is h with the because that is a component in the y, it's like this. Okay, it's a component in the y, remember. So meaning if you are replacing this guy there, it implies that your v sine theta is going to be squared, because this v has got a power 2, and written over 2g. So if that is the case, it implies that this is going to be v to the power 2, then sine power 2, then theta, like that, over 2g. Okay, that is how you find the height actually. Okay, that's the formula. So it implies that even here we're supposed to have a power 2. Okay, even here a power 2, then even here a power 2. Please take note of that. It's very important. Even here a power 2. Okay, so you can cancel this guy here, and then if you cancel this side, you remain with 1 sine theta. So this is going to be 2 cosine theta is equal to 3 over 2, and then this side we've cancelled, so we are going to remain with only sine theta there. Okay, please don't forget how I'm doing the calculations. I'm trying to negotiate because the space is too small. So this side I can say over cosine theta, even this side I can say everything over cosine theta. So this guy can cancel. Then when I cancel the cosines, I'm going to remain with a 2 here. Then this is going to equal to 3 over 2. What is sine theta divided by cosine theta? Is going to be tan theta. And then we can say over 3 over 2 over 3 over 2. Like that. I can rub on the top. Let me rub on top. Okay. Please don't get confused. What I did on top there is very simple. I just used the formula for the height, which you already know. Okay, so the formula we've reached at some point where we've got a 2 over 3 over 2, like that. Then this is going to equal to tan theta, right? So this can also be written as, this is just a 1 on top, this is just a 1 down there. So this can also be written as tan theta is going to equal to 2 over 3 multiplied by 2 over 1. So tan theta is going to equal to 4 over 3. Then this is going to be theta is going to equal to tan inverse of 4 over 3. So what is tan inverse of that? Let's check. So we say shift tan inverse of 4 divided by 3. I'm getting 53.1. So our answer in this case for the second question is going to be A. That is how you are able to calculate for this particular question. Let me just wrap the board. We solve the third question. So these questions are actually very simple. It's just a matter of understanding the formulas, especially under projectile motions. If you didn't understand, make sure that you get the projectile motion lesson under for personal tuitions. It's there, it's available. You can just inbox on the same WhatsApp number which I had projected on the screen, and you'll be able to have access to it. The third question was saying a goods train passes through a station at a steady speed of 10 meters per second. Then we have an express train which is at rest at the station. Okay, so what we can do is this. We can say data for the third question. Notice that you have a goods train, okay, which passes through a station at a steady speed of that. And then you also have an express train, which with a uniform acceleration of 0.5 meters per second. Okay, just as the goods train goes past. Now they're saying both trains move in the same direction on straight parallel tracks. How much time passes before the express train overtakes the goods train? So for you to solve such questions, okay, where you want to solve, let's say, how much time this particular object is going to overtake the other, for you to solve these particular questions, you need to know their displacement. You need to know their displacement. So in this case, let's get the displacement of the first one. So we know that the displacement of the goods train is going to equal to V initial multiplied by t plus 1 over 2 at power 2. But the question is saying a goods train passes through a station at a steady speed of 10. When they say steady speed, what are they saying? They are saying it is with constant velocity. And when the velocity is constant, your acceleration is 0 meters per second squared. So in this case, here, if you put your 0 here, this whole part is going to become 0. So we say for the displacement of the goods train, we are going to have a V initial multiplied by t, and this becomes our equation 1. Okay. For the equation 2, they're saying the express train leaves the station with a uniform acceleration. With uniform acceleration, so it means the acceleration is uniform, it's not changing. So it means that the velocity initial is going to be a 0. So for the second one, we can say the displacement of the express train, we can use the same formula, but in this case, our velocity initial is going to be 0 meters per second. Okay, so we can put our, if we put our 0 there, this whole thing becomes 0. So we're going to have 1 over 2 the acceleration, then time to the power 2, and that becomes equation 2. Now what do? We can replace in. So this guy there can also be written as x is equal to, what was the velocity for the goods train? It was 10 meters per second. So 10 meters per second, but I won't put the meters per second there, it will waste our time. Okay, then you put your 10 meters per second there, then you multiply it by the time. Okay, you say this is my equation 1. And then for the other one, you're going to say your x is going to equal to 1 over 2. For the express, they are saying that it's got an acceleration of 0.5. 0.5 multiplied by t to the power 2. All right. Now, you know, you've got your x there and you've got your x there. Okay, so while there is this x, I can replace with this equation. So this is just the same as, okay, even while there is this x, I can replace with that one so that I can get 10t is equal to 1 over 2, open bracket 5, then t to the power 2. Then I can cancel t this side and the t this side so that they cancel, and I'm going to remain with a 10 is going to equal to, what is 0.5 multiplied by 0.5? And I'm going to get 0.25. Then this t and that will cancel, you're going to get a t there. So if you say over 0.25 over 0.25, you discover that your t is going to equal to 10 divided by the answer. This is 40 seconds. So this is just how you solve this particular question. You can just get the concept and you'll be able to solve the question. So of course, for question 3, our answer is going to be 40 seconds, which is going to be our D. Question 4, they are saying a pendulum bob is held stationary by horizontal force H. Okay, so you've got something like this. You've got a bob there. And then, of course, they are saying there is a tension force which is holding it in that direction. And then you've got another force which is acting downward, which you are calling as the weight. You've got a force which you are calling as H there. They are saying the tension in the string of the pendulum is T, the weight of the pendulum bob is W, the string is held at an angle of 30 degrees to the vertical. Which statement is correct? Now, when you look at the question, they want you to just find the statement which is going to be correct. Of course, there we've got our 30 degrees. Okay, so we know that we have a component for the H which is going to be in the X, because this bob here, this guy here is feeling a force due in this direction. So we can have that is just an X component because it is in the X. Okay, so that is going to be an X component. So of course, okay, but before that, let me do this. we need to form components. We need to take this into components. So you can pay attention here what I'm going to do. So I can make two components for t because t is feeling an angle 30. Then I can take it in this manner like that. So this is going to be my tx, this will be my ty. Why am I computing in two components? Because the h has got a component which is just hx. W has got a component which is the wy, because this guy is moving downward. The force is moving downward. So let's find the ty and tx. But notice the triangle. This is your triangle. The angle is located here. So which one is going to be hypotenuse? Your hypotenuse is going to be this guy here. This is the hypotenuse. Then which one is going to be your opposite? Your opposite is always this side. So this becomes your opposite. Then which one is going to be your adjacent? Of course, the adjacent becomes this one. So this one becomes the adjacent. Then there is a concept that I gave. I said you use SOHCAHTOA, TOA. But we are not interested in the TOA part or the TOA because we don't use it under vector analysis. We're only interested in this part. But notice that the opposite is found in this particular part. It's found in this part. That's where you'll find the opposite. So if the opposite is in and the opposite is for this guy in tx, it implies that for you to find the component for tx, you say t, okay, then this is the opposite. Opposite is found in sine. So this is going to be t sine theta. Okay? Then how about for the adjacent? For the adjacent is found in k. Like that. This is the adjacent. And k is what trigonometric entity are we using? Cosine. So for ty, this is going to equal to t cosine theta. Those are our t components. Why is tx not having t cosine theta? Please look at the triangle, the way it has been put. Okay, don't get confused. Most of the triangles you use are in this particular form. Okay, that is why usually your t x, if you're finding this is your tx there and this is your ty, if you're finding using this triangle, using that concept, you will still find this is going to be tx is going to be t cosine theta in that particular posture. Okay, and of course your y is going to be t sine theta in that particular posture. But in this posture where you have something like this, your triangle has been changed, it becomes different. So now they are saying the tension is in the string of the pendulum is T. The weight of the pendulum bob is W. The string is held at an angle of 30 degrees to the vertical. Which statement is correct? So this is a pendulum bob which is held stationary. It is stationary. So when it is stationary, it is not moving. So the net force which is acting on this is going to be particularly 0. The net force acting is going to be a 0. So now, what does this show? This shows that, look, we're having something like this. If you understand these concepts, it will be easy for you to solve all the questions, even in your tests that are coming. So I said this is our T. So look, we said we formed a component of T in this direction. So this is going to be our T, Y, and then this is going to be our Tx, right? So notice that Tx, okay, if we were to take the forces in this direction, Tx is moving in this direction. So the force which is opposing it is H, this guy here, because H is moving in this direction. Okay? Those are the forces that are cancelling each other. How about on top? On top, you've got Ty, which is moving like that. Then this Ty is being opposed by the weight because the weight is going downward. Okay? So they are cancelling each other. The force going upward and the force going downward cancel each other. This is ty, this is the weight. Then of course this is going to be in the x, we had the tx was cancelling with the force going this side, which is the h. That's the concept I'm using there. So let's see what is going to be correct if we write at the end. So of course we've written our ty is cancelling with the weight. So let's check for x, for tx. Tx is going to equal to h. Then what is tx? Tx is this guy here. So it implies that our h is going to equal to t sine theta. Then how about this guy here? We have the weight. What is ty? Ty is this guy here, so it's going to be t cosine theta. So let's check what we have between this guy and this guy. What do we have? So there we do not have h equal to t sine theta. It's not there. Okay, h is not there. H, the h that we have is t cosine theta for a, which is not given us. How about for the w? For the weight, weight is equal to t cosine theta. So D is the answer. D is the answer for question 4. Our answer is going to be D. We have question 5 there. Question 5. An aircraft initially on a runway takes off with a speed of, so this is an aircraft. So we've been given the speed at the initial, which is going to be 85 kilometer per hour. How do you change this? If you are dealing with, let's say, multiple choice questions, how do you change this in meters per second? Just get it and divide by 3.5. So this is just the same as 85. As long as it is in kilometer per hour, just divide by 3.5 if you are dealing with MCQ, and you're going to get it in meters per second. So this is just the same as 24.28 meters per second. And then they're saying in a distance of not more than, so the distance is not more than 1,000, sorry, this is 1.2 kilometers. So 1.2 kilometers multiplied by 1,000 is supposed to give us 1,200 meters. Okay, what is the minimum constant acceleration necessary for the aircraft to peak? So they want us to find the acceleration. So remember, there's a formula that we use. Of course, v power 2 final is going to be equal to v power 2 initial plus 2ah. Okay, this formula. So of course from here we can pick it up. This is going to be what we want to find the time. Okay, so we want to find the acceleration rather. Okay, what is the minimum constant acceleration necessary for the aircraft? So of course we can say this is just the same one, v to the power 2 final minus v initial equal to 2ah. Okay, so over 2h over 2h. So we can say our acceleration is going to equal to, now what is v final? So it's constant, so we can just say our v final is going to be equal to 24. Okay, so our v initial rather, where it started from, because it's constant, it's not changing. So the same speed it started with, it's the same one it's moving with. So this is going to be like that. Then of course this is going to be a 0 like that. Okay, it's going to be a 0. Okay, over, and this is going to be 2. Then what is the height? It is 1,200. Okay, let me see if it's going to give me my answer, this one. So 24, okay, let me just answer. Okay, 24 0.28 to the power 2 is giving me 589.5. Then 2 over, this is going to be 2 multiplied by 1,200. And that is going to give me 2,400. So let's check what is the acceleration going to be. So 589.52 divided by the answer is giving me 0.25 seconds. Okay, so let's check what is our answer there. So it's giving me, okay, the first, I'll get A. Okay, the first question 5, it's A, 0.23. This one is giving 0.245. No wonder I just rounded it off. Okay, so for question 5, our answer is A. You can be using the same concepts even in your tests, and you'll be getting the same answer, the same answer, the same answer, the same answer. It's just one and the same thing. Question 6 is saying a body is released from rest and falls vertically in air of constant velocity. Which statement about the motion of the falling body is correct? So the body is released from rest and falls vertically in air. So look, I'm standing here, right? I'm standing here. This is the ground. And then I throw a ball going upward with a vertical speed. This ball, it will reach at some point at the top where it will start feeling the gravitational field force. Then it will start moving downward, downward, downward like that until it reaches the ground. Notice that there is a force which is pushing this object upward. It is the speed with which it is moving, the force which you released it with. Okay? So at some point, this thing will start experiencing gravity. To start experiencing some gravitational field force. Now, as it is coming downward like that, it will start feeling a certain force upward, which we are calling as the air resistance. Now, our interest is on the motion as it is coming downward. The motion as it is coming downward, the more you increase the force or the gravitational field force, you discover that the more the air resistance. So you discover that after some time, as the ball is coming down, because of increased air resistance due to increased gravity, it is going to start reducing in the speed. Okay, eventually even its speed is going to start reducing. Okay, or because gravitational field force minus the air resistance, you eventually affect the drag force, the force which is causing that object to move downward. Eventually it will start also decreasing. Okay, so let's look at the options. As it accelerates, its weight decreases. No, it accelerates initially at 9.8 meters per second, but the drag force increases, so its acceleration decreases. Very good. Okay, so that is going to be our answer. Okay, it will accelerate initially at what? 9, because this is the g. It will be at g is equal to 9.8 meters per second. This is the force with which it will be falling downward. Remember, I talked about the acceleration due to gravity like that. So I talked about the air resistance moving upward like that. If you are falling from the top, you feel air resistance pushing you upward like that. So eventually the force which will be pushing you upward is going to be increasing. It will be increasing. Meanwhile, as it increases, what happens to your acceleration? You will start moving at a very slow pace. If the two forces equal each other, you even float in the air. Okay, so of course it accelerates initially at 9.8 meters per second, but the drag force increases, so its acceleration decreases. So of course, for question 6, it's going to be a B. We go to question 7. question 7, they are saying in an experiment to determine the acceleration of free for G. So this experiment was to determine the acceleration for to determine the free fall for G. Okay, you can say free fall for G. Okay, and then they are saying the period of oscillation is considered as T, and we have got this particular length. These are the things that are affecting the whole experiment. Okay, now they were actually measured. Then they're saying the uncertainty in the measurement of length is estimated to be 4%. Okay, so the uncertainty for the length was measured to be 4%. That is for the length. For the period, what was the uncertainty? Let me check. The uncertainty is estimated to be the uncertainty in the measurement of length is estimated to be 4%. So for length it was 4%. How about for the period? It is 1%. 1%. Now they are saying calculate the value of G. Okay. But in an experiment to determine the acceleration of free fall G, the period of oscillation T, and length L of a simple pendulum were measured. The uncertainty in the measurement of L is estimated to be 4%, and the uncertainty in the measurement of T is estimated to be 1%. The value of G is given by this formula. Okay, we've been given the formula there. What is the uncertainty in the calculated value for G? So we want to calculate uncertainty in the calculated value for G. Now, you've been given, of course, the formula. This is G is equal to 4 pi squared. This is going to be L over T to the power 2. So for this one, it just tells you, okay, just tells you that actually, because this L here is feeding this 4. Okay, is feeding this 4, and of course this T which is down there is feeding this 1 coefficient. Okay, 1 coefficient. Of course, these were errors, but there is a formula to use where we say, okay, where we say the uncertainty of G, is going to equal to the percentage uncertainty of L plus, then we say 2, okay, 2 multiplied by the period. 2 multiplied by the period. Why are we getting a 2? Because we've got 2 periods. Remember, it's T to the power 2. Okay, it's T to the power 2. So of course we can get our thing here. So our percentage uncertainty for G, and then remember this is just this T there down there in this formula is just the same as T multiplied by T. Okay, T multiplied by T is like that. So okay, so this is actually the formula we're going to be using. So now what there is, this guy here you can replace with what you have there, saying it's got its error of 4%. Okay, 4%. Then for the period, what is its error? 1%. So percentage error for G is going to give you a 4 plus 2, and that is going to give you 6%. Okay, so make sure that you know this formula here. Okay, so that is how you calculate for this particular question. Okay, that is how you calculate for that particular question. It's actually simple. Okay. All right. Okay, so that's it for that particular question. It's going to be 6%, of course. We go to question 8. They're saying an astronaut on a strange planet finds that she can jump a maximum horizontal distance. Okay, so this is an astronaut on a strange planet finds that she can jump a maximum horizontal distance of 15.0 meters. If her initial speed is 3 meters per second, what is the free fall acceleration on the planet? Okay, so we shall use the same formula which I gave you. Look, this is the ground. I don't know this planet. This is the astronaut. This astronaut finds that she can jump because it's a strange planet. So we know that gravitational field force there might be either maybe low, but since they're saying that she can find that she can jump a maximum horizontal distance of that is a big distance. So when this girl jumps, she can float maybe in some air until she drops on the ground again. So the distance from this place to this place, or the distance that she took for to move from there to there, is what we are calling as the range. That's what we are calling as the range. Okay. Now, how do you find the range in a horizontal axis but affecting the y? Okay. It can also be found using this formula. So you can just say the same formula I gave you, range is going to equal to v power 2 y, yes, sine 2 theta, okay, over, this is going to be your g, like that. What is our velocity? They are saying our velocity is 3 meters per second. What is our distance? What is our maximum distance? Maximum distance is 15.0 meters. Okay. What is the free fall? They want us to calculate g. So we can cross multiply. This is going to be rg is going to equal to vy power 2 sine 2 theta. Then this is going to be over r over r. So this is going to be g is equal to, what is vy? It's going to be 3 meters per second, power 2, then sine. Then this is going to be 2, what is theta? Now, they've not given you the theta. They've not given you the theta. But you know that if you make a trajectory in this direction, please, when you are dealing with MCQs, know that all the information is present. If it is an essay question, don't even try to use the concept I'm going to use here. Okay? It won't apply. So here, they are simply trying to tell you that when this person jumps like that, okay, when they jump, they move at that particular speed, okay, from the ground, right? But you know that you can compute two components. There's going to be this guy, this component here, and then there is going to be this component. So this is going to be what? Vy, Vx. So if that is Vy, Vx, what is our trajectory there? So this implies that from this point to this point, this is going to be 90 degrees. Then this angle becomes 45. Okay? Please, don't do this if it is an essay question, and check the marks that are there. Okay? But since you're not given, you can use that particular concept for that one. So she pushed at the angle 45 degrees. So what is the distance? It is 15. Okay, so physics is very tricky. Look at the marks given. If you see 2 marks, there is less work. Okay? If you see, this is obviously 2 marks. If you see more work, if you see, let's say 4 marks, 5 marks, no, there is more work. Okay? So this is just the same as g is equal to, this is going to be 9 multiplied by sine 90. What is sine 90? Sine 90 is 1. 1 multiplied by 9, it is just 9. So this is just the same as 1 over 15. So 9 divided by 15 gives you 0.6 meters per second. You are going to find your 0.6 meters per second. We go to question 9. Okay, so question 9. We are in still air. A bird can fly at a speed of 10 meters per second. That is in still air. The bird can fly at a speed of 10 meters per second. The wind is blowing from the east. So let me create something like this. I'm going to create a compass. This is going to be my north, my south, my west, my east. This is a bird that is flying with a speed. So we can just say in still air, bird can fly at a speed of that. So that speed has not been specified. Where it's moving, it's not been specified. So I can take that speed as my v equal to 10 meters per second. What does it become? It becomes the resultant. I can take it as my resultant. My resultant. Then the wind is blowing from the east. The wind is blowing, is coming from the east. So if the wind is blowing from the east, it implies that the speed of the wind will be blowing towards the west. So you are going to say the speed of the wind is going to be negative 8.0 meters per second. Why? It's blowing towards the negative. True? Now, in which direction must the bird fly in order to travel to a destination that is due north of the bird's current position? So of course they just want us to calculate the theta and use our logical thinking, and we're able to come up with an answer. Okay, so summation of all velocities is going to equal to v for the resistant for the resultant. Then this is going to be plus v w for the wind. Okay, vw for the wind. But there is also a velocity for the bird. Okay, don't forget that there is also a velocity for the bird. So we can say that the velocity for the bird, we can name it as vb. So the bird, for the velocity of the bird, we are going to compute into two components. Okay, we shall compute into two components. The x component, which is because we have the resultant, this guy here. So for us to have the resultant, it means that you had the components in the first place. Okay, you need to be thinking in those lines. So it implies that for vb, for the velocity of the bird in the x, is going to be v cosine theta. So this is going to be vbx is equal to 10 cosine theta. Then vby is going to be 10 sine theta. Like that. Now the question is saying, in which direction must the bird fly in order to travel to the destination that is due north? So we are focusing this motion in the y. So in the y, we are using the sine. So we can get that one. Okay, so we can just say we can get this particular equation that we have here. Okay, we can get that particular equation and add it to the speed, okay, and add it to the speed of the wind, which is blowing from the east towards the west, like that. Okay, so you're going to get this and find the summation of all velocities. Okay, summation of all velocities is going to equal to, so you're going to get your 10. Why are we using 10 sine instead of cosine? I'm not interested in the cosine because the question is saying due north. So I'm interested in the one which is going upward north, the component. Okay, so sine theta, and then I can say plus negative 8. Okay, of course, we know this is meters per second. So this is just the same as V is going to equal to, okay, we can just say VB in the Y is going to equal to 10 sine theta minus 8 meters per second. I can equate VBY equal to 0 so that I have this equation. Then I can take the negative 8 on the positive so that I can have 8 is equal to 10 sine theta, like that, over sine theta over sine theta. So this is going to be, what am I even doing? Okay, so this implies that I'm now starting to get tired. Over 10 over 10. So I'm going to get sine theta is equal to 8 over 10. This is just the same as theta is equal to sine inverse of 8 over 10. So shift then sine, this is going to be equal to 8 over 10 is giving me 53.1 degrees. Okay. Now, in which direction must the bird fly in order to travel to a destination that is due north? For it to travel due north, where should it go? Should it be the west? Okay, because this question is saying already 37 is cancelled. We have 53, 53. Is it 53 east of north or 53 west of north? If it moves at 53 west of north is in this direction like that. Remember, the air is blowing this side. So if it is blowing this side, this bird will eventually move in this direction. If it will be moving towards this direction and it is feeling a force in this direction, eventually it will go like that. But if we want it to go upward, it must go where the air is coming from, so that as it goes where the air is coming from, right, this is the east, right? Remember, the force is coming from this side of the wind. So when they meet, as this guy goes east of north, what happens? They will crash like that, and eventually it will rise upward like that. So this trajectory that I've used here is what the eagle uses when it wants to rise upward. The eagle goes towards where the wind is coming from, where the waves are coming from. That is where it goes, so that when they meet, due to that resistance, okay, when they meet at some point where it moves, north, okay, trying to move upward like that. When they meet, it's pushed upward even the more like that. Okay, it doesn't move away from where the wind is coming from, because if it's moving away, eventually it will just be moving in this direction. Okay, so there they just wanted you to use the simple logic. It's actually very simple. Your physics. Okay, so of course our answer is going to be east of north, which is going to be C. Okay, so we say question 9, C. Physical quantities can be classified as vectors of scalars. Which pairs of quantities are both vectors? Both vectors, kinetic energy and elastic force. A scalar quantity is a quantity which has only magnitude but has got no direction. Vector quantity has got both magnitude and direction. Kinetic energy does not have direction, but it's got magnitude. Elastic force is a vector quantity. It's got both direction and magnitude. Momentum and time. Momentum is a vector quantity. Time is a scalar quantity. You can't measure the direction of time. Say time is going towards the north. No. Velocity is a vector quantity. Magnetic field force is a vector quantity also. Weight is a vector quantity because measured in newtons, just like force. Temperature is a scalar quantity. So the only thing which is making sense for question 10 is C. Because both are vector quantities, velocity and magnetic field strength. They use the strength instead of field force, because if they use force, you will know the answer. Okay. So, okay, let me just try to breathe a bit. So, of course, we are having our Breaktober night 2025, dated 23rd of October. It will be starting exactly 18 hours, 2:05 hours at President Stadium Mine Area near Comet Grounds. Make sure that you come for this particular night. It's going to be so interesting and marvelous. We are going to enjoy the night. We are going to pray. We are going to experience the move of God, and God is going to change our lives. Okay, so we continue from where we ended. Okay. We got to section B. Okay, so for the overnight, I'm sure there will be a bus pickup for people that will be coming from Mulungushi University. It will be there to be coming to pick you. Make sure that you get ready. 23rd of October, don't forget. We come to section B. Answer all questions. Explain how an object which is at rest and the one which is moving with constant velocity may be considered to be in the same state. Explain how an object which is at rest and the one moving with constant velocity may be considered to be in the same state. Okay, so this one, they just want us to use our logic. They just want you to use your physics. I'm going to explain. For an object which is at rest, this object is at rest. This object has got an initial velocity of 0 meters per second, and at the same time its acceleration, because it's at rest, is going to be 0 meters per second squared. This object will continue in its state of rest until an unbalanced force is acted on it. This force, it will continue in its state of rest until an unbalanced force is acted upon it. So eventually what I'm trying to say is it's going to have this object is going to have a zero acceleration. Okay? And because it's got zero acceleration, it will continue its state of rest unless someone touches it, or a vehicle maybe from behind, or maybe just a force acts on it. Okay? So what I'm trying to tell you is that the concept is that this object is going to remain with a zero net force. It's going to have zero net force. Why zero net force? Because force is equal to ma, and our acceleration is zero. So our force will be zero. How about for an object which is in its motion? An object T with constant velocity has got an acceleration of zero. When the velocity is constant, the acceleration is 0 meters per second. What does this imply? It implies that the net force which will be acting on this object also is going to be zero, because force is equal to ma. Zero here. And your force becomes 0 newtons. So both the one which is at rest and the one which is in with constant velocity, they will have 0 net force and 0 acceleration. Simple. That's all. Both of them will have 0 net force, 0 acceleration. Okay? They are in the same state. Why? Because they've got both 0 net force and 0 acceleration. So that one, they just wanted you to use Newton's first law of motion and second. I'm sure you know how to state them anyway. But that's the whole idea. That's the whole concept. B. A footballer kicks a ball on a horizontal ground, given it's an initial velocity of 25 meters per second at an angle of that. Where will the ball be at 1.2 seconds after it's kicked? Okay, so let's imagine this. Please, whenever you're doing projectile motions, just put it that way. That is, so this guy is standing here. You put it into X and Y components, because the projectile motion is just an idea of horizontal and vertical motion. And then this guy kicks a ball which makes that trajectory. Please, this won't be 90 degrees. They've given you the angle already. Okay, so this is going to be 35 degrees. And then what is the angle given? The V is 25 meters per second. They are saying, where will the ball be 1.2 seconds after it is kicked? So they want you to calculate the distance, because this guy is going to move like that. This ball, it will be moving like that until it drops at this point. So they want you to calculate the distance from here up to this particular point. What do we call that distance? It is the range. The range. So we know that the range, now the range is going to be different with that one. For the Y, we said the range for a trajectory from on the top, considering the Y, we said it was V2 like Y, then sine 2 theta like that, then over G, right? Like that. For this one, because it is in the X, it's going to be V initial T. Okay, sorry, actually this is supposed to be Vx. Okay, Vx, because it's in the X. The range is actually this distance here, from there to that point. So what is the velocity given? The velocity given is 25 meters per second. What is Vx? We don't know, we can calculate it. Remember vectors I taught? Go and check my videos on YouTube on vector that I did. You find the component Vx like this. You're going to say 25 cosine theta cosine 35, which is 25 cosine 35. So let's do 25 cosine 35. I'm getting my Vx to be 20.47 meters per second. So my range, I can put my 20.4 here. Then the time has been given to me, which is 1.2 seconds. So this is going to be the same answer multiplied by 1.2. I'm getting 24.57 meters. That's the range. Okay, that is where the ball is going to fall after 1.2 seconds. Calculate the velocity of the ball after 1.2 seconds. This one is going to be simple. Why is it going to be simple? Because range is equal to Vxt. Remember, after 1.2 seconds, it was dropping at this distance. They want you to calculate the velocity after 1.2 seconds, which is just Vx anyway. Then you put your 1.2 seconds there. So you divide like that. I know it will give you the same answer, but just solve for the sake of the marks. Divide by 1.2, and it gives you 20.47 meters per second. That is going to be our 2. Where will the ball land? Where will the ball land? For you to calculate where the ball is going to land, you need to know the time it took for it to move from here up to here. What time? What do you call that time? It is called the time of flight. It is called the time of flight. So the time of flight, okay, the time of flight, we need to calculate. Look, how far will the ball land? We know that it is still the range. We are still using the same formula. Yes, we are going to use the same form. You use the same formula, yes, because you're considering this distance in the x. But the question is, what time are you going to use? The time you're going to use is the one which is going to, the one it will take for it to move from where it was up to the end. We call it the time of flight. Now, the question is, what is your time of flight? So, of course, time of flight, your time of flight is going to be given by the formula time of flight is given by, this is supposed to be 2, okay, velocity in the y over g. I think these formulas are there in the projectile motion video that I made, I think some years ago. If you check for it, it's there. Time of flight. So this is just the same as time of flight. It's just the same as where there is Vy. We know that that is a component. Vy can also be written as V sine theta over gravity. So this can also be written as 2 What is V? It is 25 sine, that is just a component in the y actually that we are finding there, over 9.8. That is going to give us our time of flight. So let's calculate. So 2 multiplied by sine 25 sine 35 divided by 9.8. I'm getting the time of flight, the time it would take for it to move from this point to this point. In that trajectory, I'm finding it to be 2.9 seconds. That is the time I'm going to use. Okay, so time of flight. So projector motion actually, guys, very simple. Just understand the language they are using. Please, if you don't understand projectors, get the personal tutorial, projector motion at 20 kwacha only. So, I know that my range is going to equal to Vx multiplied by the time, and the time there is the time of flight. Okay, so this is going to be, what did you find? We found to be Vx was 20.47, then T is found to be 2.9, R, so the range where it would drop, when you multiply, you're going to get 59.9, so it's just the same as 60.0. This is where it is going to drop from. All right, let me just wrap the board. Wrap the board. So make sure that you pay attention. Your tests are going to be okay. Just pay attention. We go to C. C saying we have a superhero leaped with a displacement having an X component. So let's say our superhero is here. Then he leaped with a displacement having an X component, which we can call dx, of 32.5 meters. And the Y component, which we can call dy of 24.3. So we need to calculate, this is going to be our magnitude. What can I call this? Let me just call it R, magnitude. So now they are saying we calculate, find the magnitude. So magnitude is equal to, you just find the square root of dy power 2 plus dx power 2. This is not dy dx. This is the displacement in the y, displacement in the x. I can put 24.3 to the power 2 plus, I can put 32.5 there to the power 2. And this is going to be 24.3 to the power 2 plus then 32.5 to the power 2. This is giving me, okay, let me just find this. Now you find the square root is giving me 40 as a direct answer, final answer. Oh, I'm getting a 40 as my magnitude, 40.6 meters. The question goes on further to say, and this direction of the displacement vector. So direction, we know that this is just theta tan inverse. These are just vectors of displacement in the y, displacement in the x. Theta is equal to tan inverse of, what is that? This is going to be 24.3 over 32.5. So we can say tan theta of 24.3 divided by 32.5, and I'm getting 36.7 degrees. Okay, find the magnitude and direction of the displacement. So the displacement vector R, is going to be at some point, 40.6 meters at a direction of 36.7 degrees. Okay, that one was very simple actually. We go to D. Okay. We go to D. Okay, so in D, they are saying a track covers 40.0 meters in 8 seconds. And then they're asking us to find the track's original speed. Okay, so let's correct what we have. Maybe it can help us. Sorry guys, I'm so tired. Like I'm now getting exhausted. For the sake of you, I want you to pass. Okay? Everyone that follows our YouTube channel, you should make it. Okay. So we are doing G. Let's collect our data. They're saying a track covers 40 meters. The distance is 40 meters. They've given you the time to be 8.5 seconds, while uniformly moving down into a final velocity. So V final is 2.8 meters per second. Find the track's original speed. Okay, but we know that displacement is equal to 1/2 velocity initial plus velocity final plus velocity initial multiplied by the time. Okay, so in the formula, I'm sure they put the formula, except I didn't put the cover page, but the formula is there. It's actually written in this way. So from here we can cross multiply. We're going to have 2x is equal to V final plus V initial, then t. Then we are going to say over t, so that this and that cancels. Then we're going to have V final plus V initial is equal to 2x over t. And then this is going to be, we want to find V initial. Okay, so V final, so V initial is the one we want to find. Initially, this is physics. We have not put in the figures before I could get my formula. That's what you should be doing in your physics tests, exams. It becomes neat. So 2x here, I know that my distance is 40. My time is 2.8 minus sorry. My time is 8.5 minus 2.8. So what is 2 multiplied by 40? It's 80. Divided by 8.5, it becomes 9.4 minus 2.8. So 9.4 minus 2.8, it becomes 6.6 meters per second. This one was the initial. Okay, this was the initial. That is how you find the velocity there. We come to question 2. Question 2 is simply saying you imagine on your wedding day. So this one is just estimation. It's all general knowledge. Okay? Except you just have to use some concepts here and there, but it's actually very simple. It's not even hard. They're saying, imagine on your wedding day, your lover gives you a gold ring of mass. So this is the gold ring. Mass 1, when it was bought, was 3.8 grams. And then 50 years, after 50 years, this was at initial. After 50 years, you discover that it is actually weighing, it's actually weighing 3.35. On the average, how many atoms were braided from the ring each second? So they want us to find something which is going to be in atom per second. Each second of your marriage, when the atomic mass of God, so atomic mass of God is 197 atomic mass unit. And then they've given you this, they're saying one that is equal to that. Okay, so first of all, we need to find the mass loss, because we have seen that it was 3.8, but it has depreciated. So let's find the mass loss. What mass did we lose from the ring? So it's going to be the mass after 50 years minus the mass when you got it. So this is going to be 3 point. Sorry, it won't make sense. It won't make sense. Why? Because when you are subtracting depreciation, you don't subtract from what you have to what you had at first. You subtract from what you had, because the ring that you have right now is the one which has got more value. Okay, it's got more value because the gold is intact. No, it's not depreciated. So what we had at first was 3.8. I'll subtract it from 3.35. Let me see what I'm going to get. Mass loss is going to equal to, let me see what I'm getting, 3.5. So 3.8 minus 3.35. I'm getting 0. These are grams. 0.45 grams. I need to convert these grams into kgs, because from the look of things, even in the question, they're using kgs. Okay? They're using kgs. So make sure you take in the units given the standard units. The standard units. So 0.4 multiplied by 1000. If you multiply that by 1000, it's going to give you, oh, okay, so for us to put it in kgs, sorry, we don't multiply, we actually divide by 1000. The mass lost in kgs we are going to get, I want to put it in kgs, 45 kgs. Okay, that was the amount of gold that was depreciated in kgs after 50 years. The atomic mass unit of gold is 197. We can take 197 in kgs, we see. So we can say 1 U or 1 atomic mass unit is equal to 1.661 multiplied by 10 to the power negative 27. Then how about 197? 197 is going to equal x hook. Then you cross multiply, you're going to have x is equal to 1.661 multiplied by 10 to the power 27. Okay, so what you're going to get is, when you cross multiply, let me see, 197 multiplied by, this is 1.661 multiplied by 10 to the power negative 27. Okay, so I'm getting an answer of 3.27217 multiplied by 10 to the power negative 25. So this is going to be the, this was in kg, the atomic mass unit of gold in kgs. Okay, it's going to be like that. Then we are going to get this guy here, what we have here, the atomic mass of gold in kgs. We are going to divide it with the depreciation. Okay, we divide it by the depreciation. Okay, so if we divide it by the depreciation, the figure that we're going to get, we're going to multiply it with the time. That is going to be our number of atoms that actually depreciated. So in this case, we're going to say the number of atoms that depreciated is going to equal to, I'm going to get my 4 point like that. I'm going to divide it with 3.27217 multiplied by 10 to the power negative 23, like that. So I'm going to say 0.0000045 divided by the answer, and I'm going to get something like 1.3. So the number of atoms that are depreciated, the number is 1.375 multiplied by 10 to the power 21. Then whatever we have here, okay, whatever we have here now, this is the number of atoms. Now let's calculate the time after 50 years. Okay, we shall use this conversion factor. We shall say 1 year has got how many seconds? Is equal to 1 to 3. Sorry, it's going to be 1 year is equal to 3.27 multiplied by 10 to the power negative. This is supposed to be negative 25. Okay, negative 25, like that. So basically that is going to be our, sorry, so I actually got this conversion factor from one of the physics textbook, of course, for the sake of just doing things real quick. Okay, but if you want, you can break it down like that until you reach 2 seconds. Okay, so 1 year is equal to 3.27 multiplied by 10 to the power 7 seconds. Then after 50 years, 50 years is going to equal to x, and you cross multiply. So you can say 3.27 multiplied by 10 to the power 7 Then we multiply it by 50. What are we getting? So if we multiply it by 50, 0.27 multiplied by 10 to the power 7 multiplied by 50. Okay, so I'm getting a figure something like this is 1,635, then the sense 0, 0, 0, then 0, 0, 0, like that. Okay, then this figure that we have here, okay, this figure that we have here, we are going to divide it by by the mass that we got in the first place. Okay. So the figure that we're getting there, we are going to multiply it by our mass that we got in the first place. So what are we going to do from here? So we are going to say that where is, okay, this guy. So we are going to divide this guy, because this is in seconds. Okay, this is in seconds. We divide it by that guy. Let's see if we're going to get our answer. So we're going to say, what is the question on how many atoms? Okay, so how many atoms were absorbed from the ring during each second of your marriage? So atoms, okay, I'll just say atoms absorbed after each second, like that, is equal to, I'm going to get 1.375 multiplied by 10 to the power 21 over 1,635,000,000. Let me see if it will give me the answer. So 1.375 multiplied by 10 to the power 21, like that, then divide by this is going to be 1,635 million. Okay, so it's giving me something like, it's giving me something like 8.4 multiplied by 10 to the power 11 seconds. Okay, so now what is this? Remember, this was atoms, this was seconds. So when you calculate that, on the average, how many atoms were braided from the ring during each second of your marriage? Each second of our marriage, this ring is going to be losing atoms at a rate of 8.4 multiplied by 10 to the power 11 atom per second. Let me just rub so that I can write the answer properly. Every 1 second, or let me just say every after each second, this ring will be losing 8.4 multiplied by 10 to the power 11 atoms per second. Okay, at 8.4 multiplied by 10 to the power 11 atom per second, we shall be losing an atom. The ring is going to be depreciating. That is how you calculate for the first question. Let me do the second question. The first question was so long. That is how you do for the first question. So you need to solve as many questions as you can for you to at least have knowledge concerning some of these questions. We have seen this question before. I think I've seen this question before also in a chemistry question, in a chemistry lesson or lecture. A ball is thrown directly downward with an initial speed of, so this, you are standing here, and then you throw a ball directly downward. They're saying at a speed of 8 meters per second with height of 30 meters. After what time interval does it strike the ground? So you use this formula. S is equal to Vyt plus 1 over, so it will be plus 1 over 2 g to the power t, like that. Okay, but g is negative because this thing is feeling a gravitational field force which is moving downward. So this is just the same as S is equal to Vyt minus 1 over 2 gt power 2. So S is 0 because, yeah, of course we are creating an equation. So okay, sorry, V is 0, our Vy is equal to 8, and then our S is equal to 8. They want us to calculate the time. Okay, good. They want us to calculate the time. So I can replace S same as h, the height. So I can say height is equal to, where there is Vy, I can put my 8 meters per second minus, this is going to be 0.5 multiplied by 9.8. So I'm going to have this is going to be 4.9 t power 2, like that. So this is going to be, what is the height? The height is going to be 30 equal to 8t minus 4.9 t to the power 2, like that. So when you reach here, we can factorize. So this is going to be 30 is equal to, this is going to be, what is common? T is common. So this is going to be 8 minus 4.9 t. So of course we know that t from mathematics, we know that our t is equal to 30 seconds. And at the same time, we are going to have 8 minus 4.90 equal to 30. Then this is going to be negative 4.90 is equal to 30 minus 8. So 30 minus 8 is giving us 22 divided by 4.9. So our time is never negative. It will never be positive. It's got no direction. Okay, so the time you are getting is going to be 4.48 seconds. So after what time interval? Remember, it's an interval. An interval means you have 2 times. It can be 2 times or more than 2 times. So for the ball to strike on the ground, okay, the time interval will be between 4.48 seconds to 30 seconds. Expect it to hit the ground. That's how you solve this particular question. I'm going to give you question 2 as your work, which I would want you to send to my WhatsApp number plus 26077 66 40 46. Which other question can I give? Okay, I'm also going to give you this one, question 2. I'm going to do D because it's high yield vector analysis question. Okay, I can use it to help us solve some vectors. Okay, let me just get some breathing minute. Of course, don't forget this particular night. Make sure that you come for the overnight with Apostle Alex B.C. Mutale and Pastor Priscilla Mutale. It's gonna be on the 23rd of October from 18 hours to 05 hours. It's a Breaktober night 2025. Every year we have this particular night. You are going to see quite a number of posters. I'm sure you're able to see them across Zambia. Different people from different countries are coming for this particular night. Don't you forget to mark your calendar. Show up so that we may worship together. Okay, we go back to our question D. D is a question on vectors. A force F1 of magnitude, so we've got F1 of acts on an object at the origin in a direction. So look, this is going to be our diagram. We are going to have a force F1 which is going to have 6.0 newtons, and then it moved at an angle theta of 30 degrees. And then we are going to have a second force F2 of magnitude 5 which acts in the direction of the positive y-axis. So F2 will be acting in this direction. So this is going to be F2, 5 newtons. Now, for us to find this guy here, it is just the resultant they want you to find here. They want you to find the resultant. So compute F1 into components because it feels 30 degrees an angle. So I can compute it into components, going to have F1 X and F1 Y. So let's calculate F1 Y is going to equal to 6 sine 30. So what is 6 sine 30? 6 sine 30. I'm getting a 3.0 newtons. Then F1x, a component in the x, is going to be 6 cosine 30. So 6 cosine 30. I'm getting 5.19 newtons. Then I already have F2. F2, you can't compute it new components. It only has one component, and that is in the y. And that is your 5.0 newtons. So you can calculate F in the x and F in the y. So F in the x, we are going to add this guy here. Okay, we're going to add that guy there. Plus which one? Okay, plus 0. Because F2y is 0 newtons. So plus 0, we're just going to get the same figure, which is 5.19 newtons. Then Fy, we are adding this 3.0 newtons and this 5 newtons. 3 plus 5, I'm getting 8. Then we can calculate. They are saying magnitude and direction. So this is actually very simple if you understand the concepts. Okay, so to calculate the resultant, which I can call F, or the magnitude, then this is going to be Fx power 2 plus Fy power 2. Then F is going to equal to, this is going to be 3 plus this is going to be 8 power 2. So this is going to be 9 plus 64. 9 plus 64, we find the square root, we're going to find something like 8.6. Okay, I'm getting 8.6. 8.6 newtons. Sorry. Sorry. Fx we getting 5.19. Okay. So this is going to be 5.19 to the power 2 plus, what is Fy? Fy we get 8. So let me calculate now. 5.19 power 2, 26.9 plus 64. Getting 90. Then we find the square root of 90.9361. Just computing this into components and you find your answer. And I'm getting our force is equal to 9.5 newtons. This is going to be the magnitude. How do you find the direction? Simple. Make sure you solve all your tutorial questions. Direction implied by the theta is equal to tan inverse of force in the y over force in the x. Tan inverse is equal to, so this is going to be theta is going to be tan inverse of Fy is going to equal to 8. Then Fx is going to equal to 5.19. So shift tan, then we say 8 divided by 5.19. And we're getting an angle of 57.0 degrees. That is how you solve for this particular question. If you found this video interesting and helpful, consider subscribing and hitting the like button. And don't forget the massive event, the Breaktober Night 2025. Exactly 23rd of October, 18 hours to 05 hours, with Apostle Alex BC Mutale. Where exactly? President Stadium, Mine Area near Comet Grounds. Mulungushi University students, come and worship the Lord and experience a shift and a new move of the Lord. This is the mentor, Hampeyo Kliman, the son of Apostle Alex BC Mutale. Thank you so